Hello, folks, and welcome to lecture number 3 for tables and matrix revision. In case you have not seen the previous two lectures, you can find them on our profile. And if you have not attempted this quiz, you can find the link in description. Attempt that quiz first and then come back to this lecture. You'll be able to take the most out of it. All right. So without further ado, let's get into understanding a few more tips and tricks for acing this important topic of tables and matrix. Let's start with set number 1. Durga Puja and Diwali are two major festivals where film producers try to release their movies in West Bengal. 5 actors' names have been given to us, play the role of lead actors in 5 new movies that will be released in this year and around these two festivals. Okay. Each of these 5 actors acted in only one movie. Then we've been given 5 actresses' names who played the role of lead actresses in these 5 movies against previously mentioned lead actors. Okay. Each of these 5 actresses act only in one movie. Okay. Which movie, each movie has positions of only one lead actor and one lead actress. Okay. These 5 movies will be released in 5 consecutive weeks, one after the other. And no other movie will be released during these 5 weeks. So we've just been given a lot of rules in order to remove any sort of ambiguity, right? So there is 1 week, one movie, one actor, one actress. That's what we need to map out essentially. Okay. And if I quickly glance at the questions, I can clearly see that I will be able to get all the answers and will be able to make a complete table. All right. So let's get into solving this set. Okay. All right. So clue number 1, what does it tell me? Jaya's movie will be released after Dev. Sort of an indirect clue. Nothing which I can plug right now. And also I can't start making cases based on this move because there will be 4 cases or maybe more, like 4 places for Dev and subsequently more for Jaya. So I will park this for now. Clue number 2. Release dates of exactly 2 movies have been scheduled between the movies of Abir and Ankush. I think this will be a very important clue. Why? Because we have a total of 5 row items. And if there are 2 movies between Abir and Ankush, that means that is sort of covering 4 row items. So which essentially tells me that Abir and Ankush as a pair can only be in 1 and 4 or 2 and 5. That's a good limiting factor to note. Yes. All right. What does clue number 3 tell me? Nusrat's movie will be released before Swastika's movie, and Swastika's movie will be released before Subhashri's movie, but not in a consecutive week. Again, guys, if you remember from Matrix and Tables lecture 1 and 2, if I have something which is giving me 3 unique rows, that sort of becomes an important clue as well. So we will keep this in mind. Okay. But we cannot directly plug anything over here because we don't know if they are immediately after each other or how much gap is there between these two people's movies from clue number 3. Right. So it's important, but not a direct plug-in. Okay. But what can I say? From clue number 1, I know Jaya cannot be first and Dev cannot be last because Jaya is after Dev. Right. And from clue number 3, I know Swastika and Subhashri cannot be first as well because Nusrat is before them for sure. Right. And clue number 4 tells me exactly one movie will be released between the movies of Jishu and Mimi. Jishu being the actor, Mimi being the actress. Where Mimi's movie will be released later. So again, Jishu cannot be last, Mimi cannot be first. So guys, if you note from clue number 1, 3 and 4, I can for sure tell you that Nusrat will be the only actress who can be in the week number 1, the movie which is there in week number 1, because all the other actresses are coming in later. So I'll just fill in Nusrat over here, right? Okay. And then I know that Jaya is after Dev, Swastika and Subhashri I know are after Nusrat, and Mimi is after Jishu. Okay. Clue number 5. The movie of Dev will be released in the week immediately preceding the week in which the movie of Ankush will be released. So Ankush were mentioned in clue number 2. So I can see sort of some correlation between Abir, Ankush and Dev. Yes. Okay. And last clue tells me Nusrat and Dev did not work in the same movie. Okay. So I'm sure that clue is essentially to help us eliminate a few cases or something like that. Yes. So, which was the clue which was giving us the most coverage? Clue number 2, Abir and Ankush, right? Let's take that case. Let's say Abir or Ankush are in 1 and 4. Okay. Guys, can Ankush be in week number 1? No, right? Because I know Dev's movie has to be released before Ankush. So the only possibility here for this clue to fit in is Abir being over here and Ankush being over here. Correct? And therefore Dev will be over here. Right? Okay. Now, another thing that we remember is Jishu and Mimi. And Jishu could not be last if you remember. Yes? So Jishu has to be here and Mimi has to be after Jishu's movie. And one movie is released between them, which means Mimi will be here. And from clue number 1, I know Jaya's movie is after Dev's movie. So the only option for Jaya is over here. This leaves me with Swastika and Subhashri. But if you notice, they come into consecutive weeks, which is not allowed. Clue number 3. So therefore, I know that Abir and Ankush cannot be in week number 1 and 4. Right? We have eliminated that case. Let's look at the second case in that regard. I can put Abir and Ankush at 2 and 5. If I put Ankush at number 2, they will have to be at number 1. And Nusrat and Dev cannot be in the same movie. Therefore, I know that without a doubt, Abir has to be at number 2 and Ankush has to be at number 5. Dev will be over here. Jaya will be over here. Yes, correct. Now, if I put Jishu at number 3, Mimi cannot be at number 5. There has to be exactly one movie between them. So, therefore, I know Jishu has to be over here and Mimi will be over here. Swastika and Subhashri, therefore, will be over here. And the third position will be fulfilled by S. And that's it. The set is over. Again, I believe the most important thing which helped us crack this faster were to identify the points which are giving you the most coverage. In this case, it was point number 2, and of course, point number 3 with 3 individual rows. So I think we have seen this trend in the first 2 quizzes and first 2 videos as well. If you have not, please go back and see that. It will really help you crack the cases of tables and matrix. Okay, let's answer the questions quickly. Who played the role of lead actor in the movie where the lead actress was Jaya? So Ankush. Ankush is my answer. Who played the role of lead actress in the movie where Jishu was the lead actor? Nusrat. Nusrat is my answer. Number of movies that will be released between Nusrat and Dev. 2 movies. Nusrat is first, Dev is fourth. We assume that the first movie among these 5 movies will be released in week 1, second in week 2, and so on. What is the week in which Jaya's movie will be released? Week 5. Very straightforward. Right? So I believe it was an easier set. And overall, as well, I believe this was an easier quiz among the 3 quizzes that we have had for this topic. Right? All right, let's look at set number 2. Okay, this is an interesting set. The reason I picked this set out for this quiz was not that, the cat might ask this set as it is, but I think knowing this concept of inclusion and exclusion and sort of PNC application in DILR is what makes this set important for our revision. Okay, let's look at it. An artist uses 3 different types of paint bottles for their artwork. Following table represents the number of bottles of each paint brand that are categorized as A, B, and C. Okay, so I have 5 brands, I have 3 types. Okay. All right. So clearly, I've been given all the data that is required, and I know all the questions would sort of be standing by themselves because there's not a lot to really solve from the set, right? So let's get to the questions. Of course, in such cases, one thing which I've always taught you guys is how important the total row and total column is. So I've added the total row and total column to the given table, which will help us crack this set faster. Okay. Question number 1. Find the minimum possible number of paint bottles that the artist must pick from the stack to be sure of having picked at least one from each brand. So each brand means we're looking at the rows, correct? And they need to be sure of picking at least one from each brand and we need to find minimum. Guys, in such questions, you will have to think in terms of hypothetical extremes. Okay, that's the way to do this set, right? Of course, in real life, this number might not make a lot of sense, but because we are finding absolute minimums and absolute surety and proper randomness, we will have to take such hypotheticals. Okay. So if the guy wants to pick a minimum one bottle from every brand, how do we do it? It's actually pretty simple if you think about it. Yes. Let's say I pick out 5 bottles. Okay. Now it is possible that just in 5 bottles I can get each brand once, but it's also possible that I all the 5 bottles might just be of one brand. Yes. And here the way to visualize, the way I look at this type of a question is I assume that the person picking it out is completely blindfolded. All the bottles are exactly the same in touch and feel, right? And they're just picking it out from a closed box where they really do not have any idea of what they're picking out. So this helps us really eliminate any external biases in this type of a question. Okay. So how do we go about it? The way to go about it, and you can just sort of write this as a rule if you want, okay, is when I've been given that I need to find minimum possible from this type of a setup, I will add all the maximums, okay, all the maximums with the minimum total, whichever is the minimum total. So from that, I will take one. What does this mean? What does this mean? I'll explain. Don't worry. Here in Crimson, I have 26, right? Clearly, guys, the brand which has the minimum number of bottles is Azure, which has 16 bottles, right? So that is going to be our minimum over here, which we discussed. So here I will add 26 of Crimson, 28 of Emerald, 21 of Amber, 21 of Indigo. Yes. And one from Azure. Now, why am I doing this? So the reason we are doing this is, let's say I pick out 28 bottles. Theoretically, it is possible that all the 28 bottles are from Emerald, right? Let's say I pick out 54 bottles. Theoretically, it's possible that all 54 are from only Crimson and Emerald, right? So on and so forth. So therefore, in order to get the minimum possible bottles, so that I have for sure picked at least one from each brand, is to take one from the one where there are minimum number of bottles and add the rest of them as total. No. What if we do the opposite? Let's just discuss. Let's just brainstorm. What if I take all 16 from Azure, 26 from Crimson, Amber 21 and Indigo 21, right? Let's see if we do that, what happens. And if I take one from Emerald, suppose. The reason this does not work is there is a possibility that when I add all of this, theoretically speaking, I can have more attribution to Emerald and less attribution to any one brand, thereby not giving me any guarantee that all the brands have been picked at least once. So therefore, if I want a guarantee that yes, all brands have been picked at least one, I will add all the top four and then I will take one from the minimum one. With this, I will have a guarantee I've picked at least one from every brand. Of course, the easier way to do this is also 112 minus 15, right? 112 is the grand total and 15 is nothing but 16 minus 1, which is Azure's. And that will give you the answer as 97 for this. I hope that's clear. This logic is important to know. It's very easy once you've understood it. If you have not, do let me know. All right. Question number 2. Minimum possible number of paint bottles the artist must pick from the stack to be sure of having picked at least one from each type of bottle. Same logic, same logic. I will add the two maximums and one from the minimum one. Or of course, 112 minus 20 minus 1. Either ways, my answer is 93. It's a very easily doable question. You don't even need a pen paper for this once you've understood the concept. Question number 3. Find the minimum possible number of paint bottles the artist must pick from the stack to be sure of having picked at least one from each brand and type combination. So here we find the minimum number in the table, which is clearly number 2. So the answer here very simply will be 112 minus 2 minus 1, which is 111. That's the answer. I hope this is clear. This is very simple. You just need to visualize what is happening. Yes. If you want, let's just discuss quickly. Let's say I have 3 colored biscuits, right? I have red biscuit, I have blue biscuits, and I have green biscuits. How can I make sure how many should I pick so that I know I have minimum one of each? Even if I pick 5, it is possible that I don't have a red one, right? So I need to pick all 6 to be completely sure that I have all of them, at least one from each of them. So it's the same thing. Yes. So guys, in such scenarios where you're not sure of how the numbers are playing out, you can actually reduce it to easier examples and understand it yourself. It's very simple. Okay. Question number 4. The artist randomly selects 3 different paint bottles from the entire collection. What is the probability that the 3 bottles selected are of 3 different types? Since I know that I want bottles of 3 different types, right? I will pick one from type A, so 30C1, which is 30, one from type B, which is 20C1, and one from type C, which is 62C1. And I will divide it with the total combinations of selecting 3 bottles, which is 112C3. And that's it. Pretty straightforward. Yes, so the answer will come out to be this. Last question of this set. If the artist selected 2 different brands and picks exactly one brush bottle from each, in how many distinct ways can this be done? So of course, there are 5 brands, 5C2, there are 10 ways. So this is sort of a manual calculation kind of a question, right? You'll have to, let's take combinations of crimson and azure, crimson emerald, crimson amber, crimson indigo, so on and so forth, and add the totals. That's the way to go about it. No easier way. Of course, the calculation can be made slightly easier by making it in this format, right? Wherein you just multiply 26 with 16 plus 28 plus 21 plus 21 and do the same for other 4 brands. Like for Azure, it will become 16 into 28 plus 21 plus 21, so on and so forth. And you will get your answer. That's it. This brings us to the end of this set. It's pretty simple, very small concept, very niche concept, but it's always better to know it. Yes. Let's move on to set number 3. All right. Current president of the United States is meeting 5 former presidents to consult them on US foreign policy. Okay. The 5 former presidents are given to us: Bush, Carter, Clinton, Obama, and Trump. Post retirement, the 5 former presidents have settled in exactly one of the given cities. And we've been given that they are experts on one of the 5 countries. Okay. So again, a very typical matrix kind of a set. And we've been given a few clues. We need to figure out who is an expert on what country, and who is living where after retirement. Very straightforward, yes. I think the only tinge of complexity in this set was that almost all the clues were of negative type. That, this person is not living here, this person is not an expert on this, The expert on this is not living. So there's a lot of negative clues which are there, which makes it slightly tricky to actually plug in any sort of direct data, right? No worries. Let's do this together. Clue number one. The former president, who's an expert on Japan, has not settled in New York post his retirement. So Japan guy is not in New York. So this is out. Okay. So these five are my presidents. These five are my export countries. Then again, the five are cities and five are countries. And I will just cross out whatever is negated for us. Okay. So the former president, this is done. Japan, not in New York. Okay. Trump and Obama are not experts on Germany and Japan. So Trump is not expert on Germany and Japan. Obama is not expert on Germany and Japan. Okay. Okay. Clinton is not an expert on Australia or India. So Clinton is not expert on Australia, not expert on India. Okay. Bush and Carter have not settled in Chicago or Miami. So Bush and Carter are not in Chicago or Miami. Okay. Neither of them is an expert on China or India. So neither of them is an expert on China or India. Okay. Obama is not an expert on India. So clearly Trump is an expert on India. Yes. Okay. All right. The former president, who is an expert on Australia, has not settled in Miami. So Australia guy is not in Miami. This is out. Yes. The former president, who has settled in Chicago, is not an expert on Germany or Japan. So Chicago guy, not an expert on Germany, not an expert on Japan. Yes. Trump and Obama have not settled in New York or Chicago. So Trump and Obama not settling in New York, not settling in Chicago. So clearly Clinton is settled in Chicago. Yes. Yes, yes, yes. Okay. I can say a few things, but I just want to complete all the clues. I know there are a lot more deductions to be made in this. Let's hold our horses, right? Carter is not an expert on Japan. So Carter is not an expert on Japan. Okay. So this is what I know, right? I hope I've completed all the clues. Trump and Obama not settled in New York and Chicago. Okay, this is done. Now I know that Trump is an expert on India. Yes. And Trump is not living in Chicago and New York. So Chicago cannot have India. New York cannot have India. Yes. Okay. Also, Clinton is in Chicago and Clinton is not expert on Australia and India. So Chicago is not expert on Australia and India. So clearly, the guy living in Chicago, who is Clinton, is an expert in China. Yes. So Clinton is China. I can say that. So therefore, Bush becomes an expert in Japan and leaving Germany for Carter and Australia for Obama. Right. So we already know who is an expert on which all country. That is sorted for us. Very simple. Okay. What else can I do over here? Bush is an expert on Japan, and Bush is not living in Chicago and Miami. So Miami guy cannot be an expert on Japan. Yes. And since the New York guy is not an expert on Japan, Bush cannot be living in New York, leaving New York for Carter. That has to be the case. Yes. Okay. And I know Carter is an expert on Germany and is living in New York. So the person in New York is an expert on Germany. I can see that. So this is taken care of. Therefore, leaving Miami and India to be the only combination possible over here. Yes. So who was India expert? Trump. So Trump has to live in Miami. That's the only possibility that I have. Correct. What else can I know? Can I know anything else? Australia is Obama. And Obama can be Atlanta and Boston. Atlanta and Boston both are open for Australia. So that's it. I think that's all the deductions we can make. So as soon as we plug in all the negative clues and make all the very obvious Sudoku type deductions, the table gets completed very fast, right? So again, a decently simple set, in my opinion, if you would have represented it properly. Let's answer the questions. The cities settled in post-retirement as well as the country of expertise can be uniquely determined for how many? Three of them. Bush and Obama, we could not really figure out. So it's three of them. Okay. Who has settled in New York? So New York, it's Carter and Germany expert. So it's Carter. Yes. If Obama is settled in Atlanta, so if Obama is settled in Atlanta, Bush has to be Boston. Yes. And Atlanta becomes home to the Australian expert and Japan, Boston. This becomes the case. Which city has Bush settled in? Boston, clearly. Okay. Which of the following combinations is definitely correct? Carter, Chicago, Germany. So Carter is not Chicago. Trump, Miami, India. Looks correct to me. Clinton, Boston, not correct. More than one, definitely not correct. So my answer is B. And that's it. This set is over as well. Pretty straightforward, I hope. Let's move to the next set. All right. Nano Cafe has variety of 205 servings, out of which 130 use Arabica, remaining 75 use Robusta. Okay. Each serving can either be a bakery or beverage, but not both. And they've been packed in red or blue, of course, but not both. Guys, this is very similar to those one of those PYQs, if you remember. There was an FD approval, EU approval, and cosmetic kind of a set, right? In these types of sets, it's very important that number one, we have the right representation, and number two, we use the totals very, very carefully. These sets are all around using the totals column and totals row very efficiently. So let's do that. Let's do that. So I know the cafe has 205 servings total, 205. 130 use Arabica. So 130 use Arabica and 75 use Robusta. Okay. Okay. That's it. From the first paragraph, that's all I know. Total number of servings packed in blue containers is 35. So this is 35. So this becomes 170, right? Because I know the total is 205, overall total. The total number of servings which use Arabica coffee that are packed in blue containers. So Arabica, total products packed in blue containers. Let's take this as X. Okay. Is equal to the number of beverages which use Robusta and are packed in blue container. So again, let's take this as X. So this clearly becomes 35 minus X. I'm just using the totals. And since I know 35 minus X is nothing but this cell plus X, so I can say that that cell essentially is equal to 35 minus 2X. Correct? Okay. The total number of servings which use Robusta coffee that are packed in blue containers, total number of servings that use Robusta that are packed in blue containers is equal to the number of beverages that use Arabica coffee which are packed in red containers. So total servings, Robusta and blue, which is 35 minus X, correct? Equal to the number of beverages that use Arabica in red. So this becomes 35 minus X. Yes, beverages, Arabica, red, right? This number is equal to the number of beverages that use Robusta coffee. Okay. So this number is equal to the number of beverages that use Robusta coffee. So as a total. So this becomes 35 minus X, which in turn is half the number of bakery products that use Robusta coffee. So bakery which use Robusta becomes this 70 minus 2X. So guys, from this we can get the value of X. We have bakery Robusta, we have beverages Robusta, and we have total Robusta, which we have not derived from each other. So here clearly I will get 105 minus 3X is equal to 75 if I add this column. And therefore I will get x equal to 10. Correct? So let's just quickly replace the value of x as 10 everywhere. So this becomes 25. This becomes 10 and 25. 10, 25. This becomes 10 and this becomes 15, right? These two become 25 and 50. Okay. And since I know total Robusta is bakery 50 and Robusta bakery blue is 15, this becomes 35. And with similar logic, this becomes 15. This becomes 40. This becomes 130. This becomes 95. This becomes 120. And this becomes 50. I hope you were with me. Just using the total rows and total columns, the complete set cracks open. And I'm still to use one more point, right? And I just have a few more cells to fill. So let's do that. The number of bakery products which use Robusta coffee that are packed in red. So bakery Robusta coffee packed in red, 35. Is 65 less? That means there is some number 100 than the number of bakery products that use Arabica. So this is 100 as a total, and that's it. This becomes 30, this becomes 55, this becomes 150, right? And I have red as 130 total, and overall total of bakery is 150. So this becomes 20, this becomes 5, this becomes 5, and this becomes 15. And that's it, guys. The set is over. Right representation and usage of the total row and total column. That's it. That's the trick to use uh, and complete these types of sets very, very fast. Okay. Let's answer the questions. Number of servings which use Arabica coffee that are packed in blue containers. Arabica, blue, 10. Simple. What is the difference between the number of bakery products which use Arabica coffee, 100, and the number of bakery products which use Robusta coffee, 50. So it's 50. How many bakery products are packed in blue containers? Bakery in blue containers is 20. What percentage of servings with Robusta coffee have been packed in red? So total Robusta is 75. Red Robusta is 50. Answer is 66.67. What is the ratio of the total number of beverages to the total number of servings? 55 is to 205. You can simplify it and get your answer. And that's it. The set is over. Let's look at the last set. Tomato is a popular app-based food delivery company. The company did a very good business in an upscale neighborhood of a city last year. A, B, C, D are four employees of the company, each of whom delivered a number of orders over 5 days of the week, Monday through Friday. Now, the following table shows the number of orders delivered by each of these employees over 5 days in an ascending order. Okay, and we have been given a few clues. Clearly, I just need to figure out who delivered what number of orders on what day. Very simple, kind of a very standard set. But the reason I've put this in the set is so that we are comfortable with understanding how numbers really work together in this type of a set. This set is all about understanding numbers. So let's do that together. Okay. So I've made my table, person, days, and total. And what are the deliveries are given to us already in the table on the right. And we have the 5 clues. Let's understand. The day on which Alfred delivered his maximum orders was immediately followed by the day on when he delivered his minimum. And same was true for Dattu. So I know that Alfred will follow his 50 with a 21 and Dattu will follow his 50 with a 22. Correct? Okay. The day when Chandrika delivered a minimum number of orders of the week was immediately followed by the day when she delivered her maximum orders of the week. So for Chandrika, it's clearly a 30 and a 44. Yes. Bharat delivered his three highest number of orders in 3 consecutive days in ascending order. So Bharat, I know, will do 38, 42, 43 in that order on 3 consecutive days. Again, I don't know which days, but I believe this will be important. Why will this be important, guys? I hope all of us know it by now. It's a 5 row, 5 column table. And Bharat is giving, point number 3 is giving us a constraint on 3 unique rows. Same logic, just a different format. So hence, I will know that this clue is important. Let's see. Okay. Clue number 4 is a little indirect. I'll come to that in the end. Let's look at clue number 5. Total number of orders delivered by 4 employees on Monday, Tuesday, Wednesday, Thursday, Friday is given to us respectively. Wow, this is amazing. So this is 140, 132, 120, 124, and 163. Cool. Okay. Now let's look at clue number 4. Suppose we define a parameter m for each of the 4 days such that m is the difference between the maximum and the minimum number of orders delivered by the 4 employees on a given day. Okay. The maximum and minimum values of m are 29 and 16. Now this is where the play with numbers start. Guys, which is the only pair of numbers which will give you a difference of 29? It's the maximum of Dattu and the minimum of Alfred. So what I can say for sure is the day Alfred delivered 21, Dattu delivered 50. Right? So I know it will be something like Alfred delivering 50, then 21 on next day. Dattu will deliver 50 on that day and 22 on next day. So, guys, I hope you are all seeing where we are going with this. These are 3 unique rows. Bharat was talking about 3 unique rows and it's a 5-day table. These 3 and 3 rows have to marry into each other, right? And how do we do that? Let's see. And the minimum value of m is given to us as 16. Okay. Now this is where the play with numbers comes in. Let's see what pairs we can use to make that 16m value. For the sake of discussion, let's assume that we've already used up 21 and 50, right? If I take 24 as the minimum of some day and add 16, I get a 40, but there are no 40 orders. So that's not possible. Is it possible with 30? Again, no, there is no 46. Is it possible with 22? Yes, I see a 38. So it's possible with 22. That's one example. Do I see it with a 25? There is no 41. 25, no 41. No 39. No 49. No 39. So guys, there is only one combination of Dattu doing 22 and Bharat doing 28, which will give you that difference of 16. Yes. And if you remember, we had 22 over here. So that means Bharat does 38 on that day and 39 on next and 40 on the next. And that's it. We have 5 unique rows. So I know that A will do 50 on Monday and 21 on Tuesday. On which day Dattu will do a 50 and 22 over here. And this will give Bharat's 38, 39 and 40. I hope this is clear to everybody. Again, using the same logic that we have learned over the last few quizzes. If it's a 5 table or whatever, and if you have 2 clues which are giving you 3 independent rows and so on, try to fit them together because they will have to fit. Yes. Okay. Now let's look at the rest of the numbers. So we have used up 50 from Alfred and 21 from Alfred. These 3 from Bharat and these 2 from Dattu. Yes. Okay. Now let's see what else we can do. Now on Tuesday and Wednesday, I have 2 values. I need to figure out the rest of the 2 values. Let's see if I can do that. On Tuesday, Alfred and Dattu have already delivered 71. Right? So 61 need to be delivered more. Correct? So if Bharat is left with 24 and 25, let's say Bharat does 24 over here. So if Bharat does 24, Chandrika will have to do 37. And Chandrika does not have a 37. So that's not possible. Therefore, this will be 24, this will be 25. Yes, yes. And if this is 25 and 21, I get 46 and 96, leaving 36 for Chandrika over here. So this 36 is done. Okay. Let's look at Monday. Monday we have 74, correct? I need a 66. I need a 66 from Chandrika and Dattu. And the only combination which makes a 66 from Chandrika and Dattu's values is 33 and 33. Yes. So this 33 is done. This 33 is done. Okay. What else can I say? Let's look at Wednesday. Wednesday, I have been given a total of 60. Yes. And Alfred and Chandrika need to make up another 60. So the only way Alfred and Chandrika can make a 60 is 25 and 35. There is no other combination possible from the numbers that are remaining for the two of them. Yes. So this becomes 25 in that case, and this becomes 35. Correct? Which only leaves 30 and 44 over here, and 29 and 29 because they are same values over here. Okay. So for Dattu for Friday, I have how much? I have 100 and 109 and 7116. So 47 will come here and 23 will come here. And that's it. My table is complete. So guys, it's not always that the clues might be directly giving you values, but the numbers would have been such smartly designed that there would be only one or two combinations which would be satisfying a given condition. And you need to be brave enough to actually figure out those pairs, after which the set becomes very straightforward. Yes. Let's answer the questions quickly. On which day did Chandrika deliver the maximum number of orders? Chandrika, Friday. Yes. Out of the number of orders delivered by the four employees, who delivered the minimum orders on Tuesday? Of course, Alfred. The number of orders delivered on each day for how many employees can be uniquely determined? All five of them. How many orders did Bharat deliver on Thursday? Bharat on Thursday, 42. And that's it. The set is over. So, guys, this brings us to the end of this topics revisions, tables, and matrix. Tomorrow, I will see you in another topics revision. Do go to the website, give its quiz, which is already released. And yeah, I will see you in the next lecture.